So last time we did, I got everybody's age. That was really exciting. Going around getting everybody's age. And then we constructed a relative frequency and cumulative frequency. So if you were here, you remember that. Okay, I like it. Today, we're going to go the next step. So section 2.1 is all about the stem and leaf plots, bar graphs, line graphs. Those should all be pretty straightforward. Section 2.2 gets into stuff that I think we maybe haven't worked with yet. I think I showed you, did I show you an example of a histogram already created? I think we did. Mm-hmm. Right? Okay. So today we're going to look into constructing a histogram. Good Lord. That approximates the English language when I'm writing. Let me start off with something that doesn't seem related at all, and something that seems really strange, but I don't care. Let's say for some reason I wanted to panel that wall with wood paneling. Somehow this is going to relate to the math we got to do here in a minute. You with me? We're not actually going to do this. It's not going to suddenly become a project we're going to work on. But let's say I want to do wood paneling, right? And let's say this is like 25 feet long. Actually, let's make it, let's say it's 26 feet long. Yeah, 26 feet. Okay, how are we doing so far? Okay, so that wall, let's say it's 26 feet long, and I want to put wood paneling up. And I want to use 8 panels, all right? I want to use 8 panels to do this. Are you with me? And it's okay if they I got to completely cover this wall, and if it's overlapping, I can just chop a little bit off the front and the top. But they definitely have to cover the whole thing. You guys kind of with me? So, how wide would each panel have to be if I wanted to accomplish this? This is a very physical problem. What do you have to do?
It would be 4 feet wide.
Why would you say that?
Because you would have a little bit of overlap, but then you would have a total of maybe 32 feet.
Yeah, if they were 3 feet wide, if each one was 3 feet wide, would it cover the whole thing?
No.
No. So 26 divided by 8 is 3 point something.
2.5.
Blah, blah, blah. 2.5. I like it. And I can round it up to 4. So that last panel, I can just chop the excess off. Are you guys kind of with me? So I want most of them to be the same, and then the last one, putting wood paneling up, so I probably don't have the most aesthetic eye in the first place. I'll just chop some off the last one. All right, you guys kind of with me? The most important thing was the math used to do this. I want to cover that much with this many things. And so that's the math I would do to figure out how wide each thing has to be. Now that seems kind of silly on the surface of it, but let's see how that relates to statistics somehow. So let's say I had, let's make up some data real quick. I'm going to put it in order. It's always nice when it's in order. You can do stuff with it. All right, that's plenty. So I got this data here. So remember, my result, my goal is to make something that looks like this. Right? It's going to have this kind of shape to it. That's what a histogram looks like. And this is going to be classes, like from 2 to 4. Yeah, I remember that. We did do that. Good. So we got to figure out, how the hell do we make these classes? These are like the wood panels. Do you see that? That's like the wood paneling. So how wide is each rectangle going to be is going to be dependent on, well, how far do I have to go and how many do I want to use. So in general, use 5 to 10 wood panelings. But let's not call it wood panelings. Let's call them classes. Use 5 to 10 classes. Don't worry, eventually I'm going to shut up today and let you guys work on something amongst yourselves. All right? Okay. So if you're tired of my voice already, it's going to stop here sometime. use 5 to 10 classes. The smaller the data set, the less classes you want to use. So we're normally going to use 5, 6, 7. I'm not going to give you 800 data points. There's no point to that, right? Okay. Sort these. And no, Jeff, no. So first off, I want to ask you, let's say, is this a very big data set? It's pretty damn small, right? So how many classes do I probably want to use? 5, right? If it gets bigger, use 6, 7, 8. There's actually a formula that involves logarithms to try to figure out exactly how many classes would be the appropriate amount. Screw that. It's a kind of a subjective kind of thing, right? You just got to feel it out. We're probably never going to use 10 classes. Okay. So somebody help me out. Do you see the connection between what I was talking about? How much data do I have to cover? What's the range of the data that I have to cover?
9 to 67.
Yeah, and so how far is that? From 67 to 9 is?
58.
Yeah, so 58. That's the range I've got to cover. That's sort of like how wide the wall is that I want to cover. That's the range I've got to cover here. And I want to use 5 classes. So how wide does each class have to be? Stay with me now. Yeah, because what's 58 divided by 5?
11.6.
11.6, and then you round it up to 12. You always round it up to the next number. Even if it came out to be 11.1, why would it be silly to round down? If you make all your panels less than they have to be, will they cover the whole thing? No, you always round up. All right, let me stop there for a second. Is this making some sense so far? This is not intense mathematics. It's not. Not yet. Okay, cool. I like it. Okay, so now that we know how wide every class needs to be, I got a decision to make about how to show you. This book uses, I can't remember which method they use. Oh, okay, they use that. All right. I'm going to show you the book way first, and then I'm going to show you a better way. It's not my way, it's just the way I was taught, so I didn't make it up. And you'll see why the book method leaves something to be desired. So let me take this guy away here. All right, so the first class is going to start where?
9.
That's crazy. And we have flexibility. We could have used maybe 6 classes instead of 5. We could start at 9. Normally it makes sense to start at the first data point, but we could have started at 5, especially if the width was like 5 or something, you know. Does it kind of make sense? So there's a lot of flexibility. So when I give you a problem and I ask you to make a histogram, nobody's has to look the same, which is really interesting when you go to grade it, but oh well, too bad for me. So there's a lot of little flexibility in here. So my classes, well, okay, this will work. Let me do it like this. Because we're going to want frequency and the relative frequency here in a minute. We're used to those already. So my classes, I want the first one to start at 9. Now this is the textbook way. Where would the next class start, considering how wide each class is? 21. Because it's got to be how far away from 9? 12. Does that make sense? How are we doing so far? Is that cool? So the first class is going to go from 9 to something, but the next class has to start at 21 because they're supposed to be 12 apart. Let that make sense, right? Now, why would it be crazy to do this? Don't write that. Which class would I put 21 into? Is it currently well-defined? You see, 21 would go in both, and that's no good. That would count it twice. Or I'd forget to count it, one of those things. So this is really going to be 9 to 20. So you see the width here. Oh, I can tell you guys love this. Do you understand the basic idea of what we're trying to do?
Yeah.
I'm showing you the textbook way first because the textbook is the resource you have. I'm going to show you a different way that you can do it if you want to. So here's the different way to do this, by the way. The different way to do it would be to say the first class goes from 9 to 21. The next class goes from 21. What would it go to? 33. So does the first class include 21?
No.
Well, how do you know?
Because it's not equal.
Not equal to, yeah. So there's no ambiguity here. I much prefer this personally. I don't care which way you do it. I really don't. But this way is less ambiguous. You don't have to be as careful. Oh shit, I don't want to repeat myself. Oh shit. You guys, let me stop there for a second. You guys look concerned. So I don't care which way you do it. Pick one way. Alright? Okay. So this will be 21. You just keep going by 12. Go by 12. Keep going by 12, right? Become a 33. Go by 12. Make sure I'm adding 12 correctly. You never know. I don't know when I'm done. When I have 5 classes, right? And did I get to the last? Does the last data point have a place to go? Now, what is the last data point? But this is, who cares? Please, dear God, you don't have to stop at the last date. You just need a place for everything to go. Of course, this is not necessarily going to be that same last data point because it's set up by going 12, 12, 12. So don't force this to be the same. All the widths have to be the same. Okay. Sleep. Can't read you guys worth anything. All right. So what would this mean then? This freak, we've done this before, but now I'm dealing with classes. So what would I put under here for this first class? How do I figure it out? Yeah, how frequently does something show up between 9 and 20? Well, how frequently? 2, 3, 4. How about 21 to 32? 1, 2, 3. Is that cool?
Yeah.
You guys see? No, see? Nothing major. This math is nothing major. 33 to 44. 2. Is that cool? 45 to 56. 1. You guys see that? 57 to 68. 1, 2, 3, 4, 5. I like it. Hopefully these are not scores on a quiz. I'm stuck. I didn't really say what these were. Alright. Nothing major yet. So does everybody see the class width? What's the formula for the class width? Where'd this 58 come from? The range, yeah, the high minus the low. So class width in general is high minus low divided by, what was that, 5? What the hell was that?
Class.
Number of classes, kick ass. So there's the formula for that. You just got to remember that one. Oh man, that's a hard one. Sorry. Being facetious. How we go so far? Alright, and then what's going to be here is going to be that relative frequency. So real quick, how many data points do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, sir?
Is that a coincidence, the 1, 2, 3, 4?
Totally.
Okay.
Totally. I mean, I wish I could take credit that I was actually thinking ahead. Ain't no way I was thinking ahead to what these were going to be as I was... No.
Okay.
Don't give me too much credit. I should have said, well, yeah, man. No. It's totally coincidence. So there's 15 data points up there, right? What can I do right now as a quick check to make sure I'm doing everything okay so far? What's this got to be? It better add it to be 15, because there's supposed to be 15 data points. And what does this add it to be? Thank God. All right. It's a good check. It sucks when you have like 40 data points and this adds up to be 38, and you're like, oh, shit, what am I missing? All right. Okay. And now, how do I figure this out? Relative frequency, how do I figure that out? Yeah.
Multiply by 15?
Divide each one by, because it's related to what idea? Relative frequency is related to what idea? What's the better thing humans understand better? Percentages. I love it. So 4 out of 15. I said that like I wasn't human, but I am. I am human. I want to be a human teacher. Sorry. Flashback South Park. So what's 4 divided by 15? Cool, so we'll just make it like 27%. We're going to do this by hand, so you don't have to round it too much. Just got to remember, if you round these, this is supposed to add up to you. All the percentages should add up to be 100%, but if you round, it's going to be 99 or 101. If it comes out to 95 or 105, that is too far off. You did something wrong. Should be pretty close to 100. 3 out of 15, 1/5, 20%? 20%? 2 out of 15? 13.3 here? Okay. Roughly. 1 out of 15?
0.6 to 60.
It's like 7%, roughly. And then 5 out of 15, 1/3. 33, right?
Yeah, 33.
All right, how we doing? Okay, cool. And then if you do add these up, what do they come out to be? Maybe it will be 100. It comes out to be 100? Sweet. We're lucky. That won't always come out to be 100, but this one came out to be 100. Yay! All right, so I'm going to make this histogram, and then I'm going to shut up and let you guys work on an example problem. I'm going to take all this stuff away. We don't need this anymore. So let me make something up for this. Let's say these are ages of people in a photo place in the mall. You with me? Because I want to make sure you guys understand ages of people in photo place. You have to label your axes, right? Don't just give me numbers and say, there, Jeff. You're a numbers dude. You don't need, no, I need English. I need to know what the hell this is. And I could ask you either for a relative histogram or a frequency histogram. So you got to be careful about which one of these you use. Let's make a relative frequency histogram. So use real freak, right? And how far up do I need to go? How far up does that scale have to get to? Yeah, it's got to include 33, right? So maybe I can step by what? 5s, maybe. 10s might be too, well, the right word is gross, but it doesn't really come out for too big of a step, right? So maybe 5, 10, 15, 20, 25, 30, 35. I like it. Just don't go up to 100 and have all this blank space and your picture looks like this. I mean, what good is that? One thing is, those are triangles. What's wrong with you, Jeff? You know what I mean? Give your stuff space to live in, right? Don't go up to 100%. That's crazy. All right. And what about this scale here? Well, it's already set up for me, sort of. But what's wrong with this? If you saw a histogram and there was gaps in between, what would you think is true? That there's nothing in that spot. So that's not true here. Is there anywhere there's nothing in it? So I don't want any gaps. Now what's better about the other way of doing things, 9 to 21, is there's automatically no gaps. I mean, 21 goes right on top of 21. If you do it the book way, here's what you got to do. So maybe I'm going to get some converts too. Even though the other way's got inequality symbols and freaking algebra, X. People get a little worried about that. This exceptionally sucks. Because here's how you have to do it. The way to make this not have a gap in between is to say this really goes up to 20.5 and it really starts at 8.5. You got to go up and down by a half. So if I were you, even if I didn't like math any at all, I would probably use the other way. But again, I don't care. If you use this way, I don't care. It's beautiful. Whatever makes more sense. So here, I'd have to make this 8.5, 20.5, and then just keep going by 12. 32.5, 44.5, 56.5, 68.5. Yeah. Okay. So again, if you did it the inequality way, there's no need for that because they overlap each other already. Here, you got to like artificially blow it up a little bit. You see, once you do that, how far apart are 8.5 and 20.5? How far apart are they? What's 20.5 minus 8.5? 20.5 minus 8.5? It's 12. All right, so now I can see the class width here. Okay. Maybe. How we doing? What's up? Like here, I can only see 9 to 21. That's 12. Well, what's 9 to 20? That's 11. Oh, shit. So when I do this, it actually shows the class width all the way across. Okay. So, how tall will this first class be? 27. A little bit past 25. The next class? 20. 13. 7. 33. Cool. Come back in. Yes, sir.
So when you have data that comes out as decimals,
See, that's why doing this catches those decimals. Now, if you had decimals in the next decimal place down, you'd have to go to like 20.05.
right.
You see what I'm saying?
Okay.
And if you do the inequality way, you never have to change it at all.
Right.
It always catches whatever decimals you got. Again, that's why I wish more books would teach that. Well, as books still do this, I'm still going to show you this because that's the textbook way. But the inequality way is beautiful. You don't have to adjust that at all.
If you came out with 20.5 as
If there was a 20.5, if there's any decimals in your data, you have to take this out one more place than that.
One more, okay.
Yeah, so that there's no ambiguity. Yeah. All right. So I'm going to leave that up there because now I want you guys to work either on your own or with somebody else. Actually, let me show you this. Who needs a calculator? Use a borrow one. Shit. If you're near somebody, you guys share. This whole row is calculatorless. You need this calculator back. If you're sitting next to somebody with a calculator, maybe you can share. You got a calculator? Yeah. You got a calculator? No. Then you can't show me yet, buddy. Or you got one? No. Okay. You guys can share. You guys can share. It looks like I need to bring you a menu or something. Yeah, are you gonna share? Okay. Who else? You need one?
I don't know. It's here.
Oh, sorry. I got your knee. Anybody else need one? Oh, you can share with me, right? Or, you know, it's going to have to be because I'm out. It's just the way it is.
No, it's like more distraction than
All right. Before I give you this, let me show you something kind of neat.
The way that he kind of says there is no difference. You're asking a lot of questions.
What's up?
So the way that you taught us, like the inequality, is basically like it's not going to affect anything else except for how you're running your history.
Yeah, so if I did it this way,
Yeah.
real quick.
Yeah.
It would be like that.
Yeah. So it's just writing in
So
different
then
way.
here, this would be 9, 21.
Okay.
Nice whole numbers.
Yeah.
Yeah.
So it doesn't make any difference affecting the problem. It's just how you're writing.
Yes. The problem would end up looking exactly the same. Yeah.
Wait, 32, right? 21 to 32.
No, 33. 21. Because why did I have to do this? Because I had to go one down so there's no overlap. But here it's less than 21 and this is equal to 21, so there's a definite spot for 20. That's the advantage the inequality has. And I don't have to adjust for decimals. Alright, maybe. Maybe. Okay. Can somebody... Do I have lights up here? Yes, I do. Hey, I'm okay. Am I okay? Hey, look at that. Sweet. Alright. So let me just show you a couple things on the calculator real quick. Actually, let me show you this too. All right, there you go, Jeff. Right there, yeah. Okay. So, if you haven't done the surveys yet, there they are, right? Do it. The day's not over yet. Maybe stop by the library on the way out and check them all and do it. You don't have access at home. Blah, 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 blah. Why am I here? Shit. I still need to post the graphing calculator notes. So I need to do that. Just now realizing that. That sucks. Oh no, don't even tell me. Oh, that's alright. I can just use mine.
Yeah.
Okay. So they don't. Alright, that's alright. Normally, the computers that we use have like a TI graphic calculator emulator, but this one doesn't, so I gotta use mine on here. So this is gonna be interesting. Okay. Zoom, 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 zoom. So if you pay a little extra money, you get this one that's got like colors on the grass and stuff, and it's backlit. I got it. Sorry. So one of the perks of being that guy. All right. Do that. How many guys have never used a graphing calculator before at all? Okay. So very quickly, if you've used a scientific calculator, hopefully you've done that, where it shows you everything you plug in all at once, like that, right? Not the old style where you put 4 minus 7, the 4 disappears. That is not good for advanced level computations. Right? You don't want that kind of calculator. Good God. Bam. Something really cool for us, there's going to be kind of long formulas that you don't want to retype. And there's going to be long answers that you have to use again. So one thing is, if I just hit the division button, it's going to assume, what the hell does that mean? What is, so that, what does that mean? Beautiful. So it's like temporary memory. It holds the last number that showed up on the screen. So it's beautiful. The last number showed up on the screen was 8.111145. I don't want to type all this shit out. You can just, and then there's an answer button. I'll show you. So let's say answer. So I just hit divided by, and it said, oh, you want to divide that last number by something. Let's divide it by 8.4. Yep. Now let's say I wanted to do, I don't know, that thing cubed, let's say. So then I can go, see this down here says ANS? So that's the same thing. So I can say second. That's like my shift key, the second. ANS. Bam! And then I can just, now how do I cube that? Here's what I call the to the button, the little caret. To the third power. So it'll be the last thing on the screen raised to the third power. There you go. Neato.
Is there a key shortcut in yours?
There is. Yeah, if you hit the math button seems to be a really good button to hit. There's a cube for us, right? And there's even a third root and an anything root. I call this one the fruit button. I'll show you what I mean. If I wanted to take the 7th root of this.
Oh, God, okay.
7th root of the last thing on the screen. Bam! And of course, odd roots can handle negatives, so that's why I didn't freak out. If I tried a square root, it would say error or something syntax. Can't take a square root of a negative number, right? Okay, cool. I like it. Okay. All right. So that's some basics. That's, there's more basics to get used to, but the ANS button is really good. That's the most useful memory button. And then, let's say you have this long thing. Let's say 7 plus 5 times 8 divided by 14 minus 5 times 7 plus 2. And you're like, oh, shit, that was supposed to be a plus. And that's not that long, really. But then I can just hit second. Or actually, on this one, you can just hit the up arrow. But if you have an old school one, you hit second, enter, and it just brings up the last thing, and then you can just move around and change it. Command. That kicks ass. You guys understand what just happened? So that's really nice, because we do have very long formulas eventually in this class. And if you put one thing in wrong, so now you just second, enter, and put the right thing in there, you're fine. Sweet. All right, those two things are the most important immediate things for this kind of class. The ANS button and the second enter thing. Real quick, if you have a calculator, if you hit the square root button second, square, the square root, and start putting things in there, does the square root grow? Do you see that? Some of you guys might have one where the parenthesis opens. That's the old one. Anybody have that? It's all right. Don't. I think everybody got one from me should have the new one. Nobody wants to admit they have the old one. But if you have the old one, you go to the Math Study Center, they actually upload the new RAM for you. If you take your calculator there, hopefully they're still doing that. They were doing that last semester. So.
What difference is it?
Say again?
What difference is it?
It's just so much better. It's so much. I mean, it used to be, if you close the parentheses too soon, it's out of the square root. Well, here I can see everything I've typed so far is in the square root, because the square root grows. So that's the newer version. And see how the cubes look like powers? So before it was like, if I typed 7 to that, it would just have a caret. Now it actually goes up to the exponent, so it looks more like what it would do if I wrote it. So the newer RAM, the newer operating system here uses more like what it would look like if I wrote it. So I mean that's useful, right? I was jealous of this until I got a calculator with it. So I'm like, oh, all right. I'm like math geek. What do you want from me? All right, how are we doing?
They can update like.
They can update it. Go to the Math Study Center. They should still be able to update it for you. They were updating it last semester. Yes, cool.